Okay, so when we want to verify this trig identity, the first thing we want to do is pick the more complicated side, which obviously is this sum of two fractions, and we're going to start with that as our given information. So sine of a divided by the cosecant of a plus cosine of a divided by secant of a, and next to each statement we list a reason for that statement, and this reason would be that it's given information. Okay, now there are a few different ways we can go about doing this verification, so I'll go through a couple of them with you in this video. The first one, if you remember, cosecant is the reciprocal of sine. So if I substitute in, this would be sine divided by 1 over sine, and you do your reciprocal, that would be sine squared a. And same thing then in the second fraction, secant is the reciprocal of cosine. So this would be cosine divided by 1 over cosine. You take your reciprocal and you have cosine squared a. And that was in our reason next to it. We're applying the reciprocal identity. And we did a reciprocal identity for sine and a reciprocal identity for cosine. Okay, then what we're left with is sine squared a plus cosine squared a. That's the Pythagorean identity, and that equals 1. So we would replace sine squared a plus cosine squared a with a 1, and then our reason next to that statement in the proof is Pythagorean identity. And then we look at what we ended with here is a 1, and that matches what our goal was up at the top here, was to make it equal 1, and so we verified the identity. Okay, just to show you another path that you might have taken with this verification, I'll go ahead and go back to where we started here at the beginning. And our first step there would be our given information. So we'll just write given so I don't have to rewrite that whole thing again. Okay, so that first step is just the sine of a over cosecant of a plus cosine of a over secant of a as our given. And then if we wanted to get a common denominator as a different strategy, we would have sine of a over cosecant of a, and we would multiply that by secant of a over secant of a. And that would get us a common denominator of cosecant of a times secant of a. Then same thing for the second fraction. We'd have cosine of a over secant of a, and then to get that common denominator, we would multiply this by cosecant a divided by cosecant of a. And our reason would be LCD, finding a least common denominator. Okay. Then in the next step, we want to simplify these, and in our numerator, then we would have sine of a times secant of a plus cosine of a times cosecant of a, that would be the new numerator, all over, and since we're adding these fractions, that is all over the common denominator, cosecant of a times secant of a. And that was addition. So using that product identity, sine times secant, that's equal to tangent. So we're going to replace sine times secant of a with tangent of a using a product identity. And then same thing for cosine times cosecant. Cosine times cosecant is cotangent of a. So now in the numerator, we've condensed that down into the tangent of a plus the cotangent of a, and then that's all divided by cosecant of a times secant of a, and then our reason for that one that we write next to it in the proof is going to be product identity. Okay, So now we're going to do a reciprocal identity with secant and cosecant. So since cosecant is the reciprocal of sine, we're going to multiply up here by sine. And since secant is the reciprocal of cosine, we're going to multiply up here by cosine. And that gets rid of the denominator altogether, and we still have in the numerator tangent of A plus cotangent of A. And then our reason that goes beside that is reciprocal identity. Okay. And then in our next step, now we need to distribute. So we're going to have sine A times cosine A times tangent of A plus, and then sine A cosine A cotangent of A. And that was doing the distributive property. Okay, and now if we change tangent into sines and cosines, then we have sine A cosine A, sine A divided by cosine of A, and that's using a quotient identity, and the cosines will cancel, and we're left with sine squared A. Okay, then on the other side we have sine A cosine A, and cotangent, when we use a quotient property, would be rewritten as the cosine over the sine. Then the sines cancel and leave us with a cosine squared A. And sine squared A plus cosine squared A is 1. So this third from the bottom, that step was using a quotient identity. And then our second step from the bottom, that was applying a Pythagorean identity, right? And you can see that that path of getting a common denominator took us 1, 2, 3, 4, 5, 6, 7 more steps than we would have had we just done that reciprocal identity right at the beginning. But that's one of the tricky things about verifying trig identities, is that you don't really get a feel for what the shortest route is going to be until you do a whole lot of them for practice, right? They're like puzzles. So the more that you do, the faster you get, the more patterns you start to recognize, and the quicker you'll pick up on a sense of which way is the faster way to get there. But even though this second approach of getting a common denominator took us a lot more steps, it still was just as valid, as was the shorter method that we tried first. Okay, so I hope that helps.